Hey everyone, welcome back to the channel. Have you ever wondered how good a LLM is for a real-world NLP competition, especially languages that don't have billions of examples on the internet? That's exactly what we're exploring today, and let me tell you, the results are pretty good. African languages represent a massively underserved area in AI development. That's why multilingual LLM are more appealing, like Google's newest open-source LLM, Gemma-3 model, which is pre-trained for over 140 languages. To evaluate the real capability of Gemma-3, we put it to a real-world test, the Lelapa AI Buzuzu-Mavi challenge on Zindi. It includes 3 tasks: sentiment analysis, machine translation, and natural language inference, all in African languages, Hausa and Swahili. This is the 3rd episode of the series. Previously, we discussed how to fine-tune a small language model with QLoRa and balance the loss of 3 tasks. So how does Gemma-3 4B perform? Pretty well. It got a score of 0.38 using a completely zero-shot approach. That means Gemma-3 can get the top 10 on the leaderboard without seeing or being trained with any labeled examples. With a much bigger model, I get a score of 0.5, which is top 3. But there's a catch. What makes this competition particularly interesting is that it's not just about performance, it's about efficiency too. The organizers actually penalize larger models, encouraging participants to achieve great results with smaller, more deployable models. This makes perfect sense for regions with limited computing resources. Gemma-3 4B is a 4 billion parameter model. To actually qualify for prizes, we need to distill this knowledge down to a much smaller model called Incuba LM, which has just 0.4 billion parameters. That's like compressing a textbook into a single page while trying to keep all the important information. So how are the submissions evaluated? The final score is basically an average of 3 F1 scores, but there is an important factor: the penalty of the model size. Here is the overview of my approach. I tested the zero-shot capabilities of Google's recently released Gemma-3 4B model. Zero-shot is just a fancy way of saying the model has not been trained on the provided labels, and no examples are included in prompts. The key to making this work was in the prompting. For each task, I had to carefully craft instructions that would guide the model to produce the exact format of output I needed. Specifically, the system prompt specifies the task and format, while the user prompt provides the actual input data. So for each task, a specific system prompt is designed. It should be noted here, we provide no examples nor any definitions in the prompts to demonstrate Gemma's zero-shot capability. For this experiment, I used Hugging Face's Transformers library with special support for Gemma-3. The whole thing runs on a standard Kaggle notebook with a T4 GPU, which is completely free. Let me walk you through each task. The first task is sentiment analysis in Hausa and Swahili. This means classifying text as positive, negative, or neutral based on the sentiment expressed. Here's an example from the dataset. It's a tweet in Hausa that looks like this. To get the model to do this correctly, the system prompt needs to be direct and clear. Your task is to do sentiment analysis. Your output must be one word: positive, negative, or neutral. Don't output any explanation. This clear instruction is crucial because large language models love to explain their reasoning, but for this competition, we just need that single-word answer. The Gemma model is good at instruction following. It outputs exactly one word, negative, as instructed. The second task is machine translation from English to either Hausa or Swahili. Translation is generally considered one of the more difficult NLP tasks because you need to preserve both the meaning and the nuance while converting to a completely different language structure. For this task, the system prompt is: your task is to do translation from English to another language. Your output must be the translation only. Don't output any explanation. This task took quite a bit longer at about 4.2 seconds per example. This time, Gemma outputs a translated sentence instead of a word. The third task is XNLI, which stands for Cross-Lingual Natural Language Inference. This task requires the model to determine if a claim logically follows from a premise. Given a premise, the model needs to decide if the claim is true, entailed by the premise, false contradicts the premise, or neither. Gemma again provides a perfectly formatted answer. A single word, neither. So how did all of this zero-shot prompting perform in the competition? Pretty well. The overall score of 0.38 is good enough for top 10 on the leaderboard if we ignore its model size penalty. It is impressive, considering the model is not fine-tuned on the task. Looking at the inference speed, sentiment analysis took about 0.5 seconds per example, translation took about 4.2 seconds, and natural language inference was the fastest at 0.7 seconds. All of this running on a standard T4 GPU on Kaggle. Now, let's talk about the elephant in the room. To actually qualify for prizes in this competition, you need to distill the knowledge from this 4 billion parameter model down to the much smaller Incuba LM0, 4B model, which has just 400 million parameters. Knowledge distillation is a process where a smaller model learns to mimic a larger one, kind of like a student learning from a teacher. The teacher, Gemma-3, solves the problems, and the student, Incuba LM, learns to produce similar answers. But there's an ethical consideration here that I want to highlight, and this is really important for any competition setting. It would be easy to get a high score on the leaderboard by simply making the small model memorize the test data prediction results from the larger model. But that might not generalize well in the real world and doesn't demonstrate true model capabilities. Instead, the right approach is to distill only using training data, keeping test data solely for holdout evaluation. This way, we're actually testing if the smaller model has learned generalizable knowledge, not just memorized specific answers. So what have we learned from this experiment? First, Google's Gemma-3 4B model shows strong zero-shot multitask capabilities for African languages. Even without using the provided training data, it can handle sentiment analysis, translation, and inference tasks with competitive performance. Second, prompt engineering really matters. The careful crafting of instructions made a huge difference in getting the model to produce the exact format of output needed. And finally, there's a genuine possibility that we can distill this knowledge into much smaller models, making advanced NLP capabilities accessible even in regions with limited computing resources. The next steps for me are to implement proper distillation using only the training data, explore different distillation techniques, and hopefully maintain as much of the performance as possible while shrinking the model by at least 90%. If you're interested in the full technical details, the notebook is available on Kaggle. I'll put the link in the description below. It's fully reproducible, so you can run it yourself to verify the results. If you found this walkthrough helpful, please subscribe to the channel for more content on AI, machine learning, and data science competitions. Drop a comment if you have questions about zero-shot learning or knowledge distillation. I'd love to hear your thoughts. And stay tuned for my follow-up video, where I'll show you the results of distilling this model down to Incuba LM0, 4B. It's going to be a fascinating journey. Thanks for watching, and I'll see you in the next one.